Welcome back to my channel. This is Pragya Jain, and in this video we are covering a topic of k-mean clustering, which comes under the topic of clustering. So let's get a brief about what is k-mean clustering. K-mean clustering is an unsupervised machine learning algorithms that groups similar data types into distance cluster. Basically, a k-mean clustering is assigned data points to the one of the k clusters depending on their distance from the centroids of a cluster. It starts randomly assigning the cluster and the centroid in the space. Then each point is assigned to one of the cluster based on the distance from the centroid. After assigning each point of the cluster, new cluster and centroids are created. This process runs repeatedly until it finds a good cluster, and it analyzes. We assume the number of cluster is given the advance we have to put the points in one of the group. So understanding the k-means cluster algorithms, like how it works in real world. So first we have to initialize the centroids. Though we have suppose we have a data sets of 10 members or 10 elements in it. You have randomly selected 2 points and assign them to as a centroid. Then assigning points. Assign each data point to the nearest cluster. Now we calculate the distance of that centroid to that particular element, and then assign that cluster and assign that point to C1 or C2 according to the distance which is less from the element. Then update the centroid. Then recalculate the centroid based on the mean of assigned data points. So in short, you have a data set and you have to take 2 points from it and randomly selects 2 points from it, assign them to a centroid. Then compare their distance from every element in the dataset and assign that element to that particular cluster based on the distance between them. The lesser the distance is assigned to that cluster, that element is assigned to that cluster. And then after completing this process, I would repeat this process until you find the particular clusters or the main useful clusters. Okay, so now select the appropriate number of clusters, like how many clusters you can create. So you have two methods for this. First one is elbow method and the second one is Celoth analysis. The first one is elbow method. The elbow method is visualize the sum of square distance to find the elbow point, which suggests the optimal number of clusters. The next one we have is Celoth analysis. The Celoth analysis score measures or how well each data point fits into the assigned cluster, helping to determine the ideal number of clusters. So now we have a data preparation and pre-processing. So we have a feature scaling, handling missing data, and dimensionality reduction. The feature scaling means that to ensure all the features are on similar scale to prevent certain features from dominating the cluster process. You have to ensure that all the features are on the same place because this will lead to the deadlock situation, like the some of the features are dominating and the other one are getting neglected. So you have to scale them on equal basis. The next one we have is handling missing data. Replacing missing values using techniques like mean median imputations or more advanced methods like KNN imputations. You have to handle the missing data. This method is very useful for data preparations for further analysis. The next one we have is dimensionality reduction. Apply techniques like PCA to reduce the number of features while preserving the most important information. Okay, so here we are implementing k-mean clustering using Python language. So in first we have to import the libraries. The necessary libraries are NumPy, Pandas, Skillet. And to access k-mean clustering algorithms, you have to include or import these libraries first in your code. Then you have to fit the model, create a k-means object, set the number of clusters and fit the model to the data. Then you have to predict the clusters. Use the fit model to predict the cluster assigned for each data points. Then you have to evaluate the result and print the result, of course. Analyze the cluster assignment, centroids and the other metrics to access the quality of the cluster. So these four are the basic you can say the algorithms in Python for measuring the k-means cluster. For visualizing the cluster, you can use these three libraries in Python, that is the scatterplot, centroids, and dendrograms. The scatterplot visualizes the data points and the cluster assignments in 2D and 3D scatterplot. The centroids plot the cluster centers to understand the position and the distribution within the data, and the dendrogram use hierarchical clustering to create dendrogram, which can help to determine optimal number of clusters, like how many clusters are used. So the scatter plot is usually like scattered all the data points in 2D 3D structure. Then you can use a centroid for the cluster centers for their better understanding of their positions and the distributions. Then you can use a dendrogram for the use for optical number of clusters. Then you have evaluating the clustering results. You have to evaluate the cluster results. So this includes inertia, Silhouette score, and we have in inertia the sum of square distance of data points to their assigned cluster centroids, which should be minimized. The next one we have is measure how well each data points fit into the assigned cluster with ranging value from -1 to 1. The practical use of this k-mean clustering, or how this can be used in real world, is that the customer segmentations, in image segmentations, anomaly detection, and recommendation system, you can use k-mean clustering in many processes. Some of the examples are given in the screen, and we'll see like customer segmentations, grouping customers based on their characteristics, behavior, preference, or improving marketing strategies and handling customers in a better understanding. You can use in image segmentations, like partitioning image into multiple segments for identifying objects and feature extractions and patterns using this. You can use for anomaly detections, like identifying outliers or unusual data points that don't fit into any discovered clusters. So that is for the video. I hope you understand. Thank you.